Hello, my fellow mathematician. Welcome to second order nonlinear constant coefficient O.D.E. We are going to solve d squared plus 4d plus 4, everything into bracket y is equal to 6 sine of 3x. Now here, in order for you to solve this, you note the following, that d squared is the same as second derivative of y with respect to x, and d is the same as first derivative of y with respect to x, which is given as y single prime. So this non-homogeneous equation has two parts. We have what is called complementary part. Complementary part reduces to d squared plus 4d plus 4 into bracket y. This is equal to 0. Now, in order for us to solve this, we are going to let y be, this is the complementary part of our given O.D.E. y is equal to exponential mx. We are going to let that, so that now we get our y prime, which is equal to m exponential mx, and y double prime is equal to m squared exponential mx. That is differentiating y twice. Now, using this fact that d squared is the same as y double prime, we are going to substitute the values here. So we shall have m squared plus 4m plus 4 into bracket exponential mx, which is equal to 0. Now, in this equation, we note that exponential mx cannot be equal to 0, meaning that the quadratic part is the one which is equal to 0, this quadratic part here. So m squared plus 4m plus 4 is equal to 0, which can be written as this equation. Note that we can write it this way: m squared plus 2m plus 2m plus 4 is equal to 0. We factor m plus 2 into bracket plus, we factor 2 here, 2 into bracket m plus 2 is equal to 0. So this quadratic equation can be written as m plus 2, m plus 2, which is equal to 0. That way, meaning that our m1 is equal to m2, which is equal to -2. So our complementary part will be y complementary is equal to c1 plus c2x into bracket exponential -2x. Then we go now to the particular part, to the other part on the right hand side, the function of Rx. We are given Rx is equal to 6 sine of 3x. Now we are going to attempt the solution of the form yp, p stands for the particular, yp is equal to a sine of 3x plus b cos of 3x. That way, then we get y prime will be equal to 3a cos of 3x minus 3b sine of 3x. Differentiating that is what we are going to obtain. We differentiate this again. Y double prime is equal to -9a sine of 3x minus 9b cos of 3x. So that is what we obtain. Then substituting in our equation is y double prime plus 4y single prime plus 4y is equal to 6 sine of 3x. So we substitute where we have y double prime, we are going to write this negative 9a sine of 3x minus 9b cos of 3x. Then multiplying by 4, so you have 4 times 3, which will give you plus 12a cos of 3x. Then you have 4 times negative 3, so it will give you negative 12b. This part here, sine of 3x, then plus 4y. Our value of y is there, so you have 4a sine of 4a sine of 3x plus 4b cos of 3x. Then with that, now we collect the terms with the sine of 3x and we simplify. So collecting the terms with a sine 3x, here we have 9, negative 9a, and this is negative 9a, and we have this other part here, which is 5b, meaning that now we can write it as negative 5a minus, you have 12. The part with b, sine of b, are as follows. You have this other part here with the sine b, so minus 12b, this is 12b, that into bracket sine of 3x, this will be equal to 6 sine of 3x, using this one there. The other part with cos, you can see here you have 12 bracket a, then you have negative 9 and positive 4, which will give you negative 5b. So factoring the coefficient of cos, we get this. So here, these are two equations. Here we are going to have negative 5a minus 12b, which is equal to 6, and 12a minus 5b is equal to 0. So this is a simultaneous equation which can be solved by multiplying the first equation with the 12 and the second equation with the 5 to obtain the following. So multiplying the first equation with the 12 and the second equation with the 5, we shall obtain this one, and we can add them to eliminate a, so that you get 0 minus 169b is equal to 72, which means that our b is equal to negative 72 over 169. Multiplying this equation with the 5 and this other equation with the 12, we obtain the following. 25a minus system b equals that 144a minus system b is equal to 0. So we can eliminate b by subtraction. So this will give us this will give us the 169a, which is equal to that, meaning that our a is equal to that divided by 169. So, and we have obtained our b is equal to 72 negative over 169. So we can let our yp to be, equal to a sine of 3x plus b cos of 3x, meaning that our yp is equal to negative 30 over 169 sine of 3x minus 72 over 169 cos of 3x. So our solution will have been given by y is equal to yc plus yp, which is equal to c1 plus c2x, everything bracket, exponential negative 2x minus that over 169 minus 72 over 169 cos of 3x. This other part here, there is sign of 3x, sorry, sign of 3x. So our solution of one given O.D.E, this is our O.D.E, was d squared plus 4d plus 4, everything y is equal to 6 sine of 3x. Our solution of the given O.D.E is this one, exponential negative 2x bracket c1 plus c2x minus that over 169 sine of 3x minus 72 over 169 cos of 3x. So thanks so much for taking your time to study with me. For more such studies, kindly tune on to my YouTube channel so that we may continue learning together. Bye bye. See you in the next presentation.